Our next lesson is linear functions. In this lesson, we'll be drawing straight lines on a graph. So if you want a straight edge to draw nice lines, you may get one. I'm just using an index card that I folded in half to make a nice straight edge that's thick. You can also use a ruler. All right, the first thing we're going to start with linear functions is just graphing using tables. Hopefully you used some tables last year. For this one, we're going to make sure the equation is solved for y. So if it's not solved for y, we're going to go ahead and solve for y. Step number 2 is we're going to make a table with at least 5 values. The next thing we're going to do is we're going to connect the points by graphing those points. And then we're going to draw a line through the points, and we're going to make sure we put arrows because the graph itself does not stop at those 5 values. So make sure you draw arrows to show that this is a continuous graph. Our first equation that we're going to graph is y equals 2x minus 1. Now, the first step is to solve the equation for y. Well, this already has this y by itself, so the equation is already solved for y. The next thing we're going to do is we're going to make a table with at least 5 values. This is our table to show our x and y values, our input and our output. Okay, when I do my graphs, you can see here I have 1, 2, 3, 4, 5 negative x values and 5 positive x values. I like to show a range between the negative and the positive to see what this graph looks like. So the points that I'm going to choose to input into my equation are -2, -1, 0, 1, and 2. I've chosen those values because I just want some positive and some negative so I can see where this graph is showing up on the line. The next thing I'm going to do is x is my input. So I'm going to plug all of those values into my equation for x and find out what the y values or the output is on the graph. So for this first equation, I'm going to plug in, I'm going to say 2 parentheses where I'm plugging in this -2 minus 1. So all I've done is rewrite this equation and plugged in the x value of -2. And then we can solve. 2 times -2 is -4. -4 minus 1 is -5. So for the input of x at -2, I have the output of -5. I can graph that point by graphing on the x value first, -2, and then my y value down to -5. So I have my first ordered pair plotted at -2, -5. The next thing I'm going to do is I'm going to plug in -1. 2 times -1 is -2, minus 1 will give me -3. So this point reads -1 that I inputted, -3 for my outputs. So -1, -3. Next I'm going to plug in 0. 2 times 0, it will be 0, minus 1 will give me -1. So 0 on my x this time, so I'm not going to move left or right, but -1 for my y. Plugging in +1. 2 times 1 is 2, minus 1 gives me +1. So 1, 1, +1 for x, and this time up for +1 for y. And my last value, 2 times 2 minus 1, will give me 4 minus 1, which is 3. So my last point that I'm graphing is +2, +3. Now this came out nicely on our graph. We can see lots of points on there. You could have also chosen -3, -4, -5, any of these values to plug in for x, as well as +3, 4, 5, 6, and so on. I'm going to go ahead and graph the points together and draw a line through them. Now, like I said, you could keep going on and on with these points, so I am going to put arrows on both sides showing that this line will actually continue going on. All right, we have graphed our first linear equation using a table. Our next one y equals -2/3 x plus 1. I'm going to make my table with x and y. Notice because my y value is already solved for, so I don't need to solve for y. Now the values, you can choose any values to plug in to your x values. You can still use what we used in the first example of -2, -1, 0, 1, and 2. But if you notice, you're going to be multiplying those values by a fraction of -2/3, which will get you some fraction answers. So what I'm going to do is I'm going to think about this division by 3, and I'm going to multiply by values that will cancel off and make no decimals. So the values that I'm going to use for this one are -6, -3, 0, 3, and 6. Now you can use the same values as before. You will just have some decimal answers. When I plug this in, I'm going to first plug -6 in for my value of x. You can also continue writing this out like we did in the first example, or you can use a calculator to plug these values in. I'm going to do these in my head. I have -2/3 times -6. And that will cancel. Let me write this to the side here, show what I'm doing. -2/3 times -6. We're going to cross simplify like we had done in an earlier process. The negatives will cancel each other. And the 6 and the 3 will also cancel each other because 3 goes into both of them evenly, 1 time and 2 times. So on top now, I just have 2 times 2, which is 4. And then I'm going to add 1 to it. So when I plug in -6, my output is 5. Plugging in the next value the same way, -2/3 times -3, the negatives will cancel again. This time the 3's will cancel each other to 1 and 1, and I'm just left with +2. +2 plus 1 will give me an output of 3. Next, plugging in 0, 0 will cancel out completely the -2/3, plus 1 will give me 1. +3 will cancel the 3's, but not the -2 this time. So -2 plus 1 gives me -1. And then 6, +6 will cancel the same way as we did over here, except it won't cancel out the negative sign. So I'm left with -2 times 2 plus 1, which gives me -3. Once again, you can also plug these into a calculator if that helps. And next I'm going to plot all of my points. -6, +5. There's my first ordered pair. My next point is -3 for the x, +3 for the y. Notice this line that I'm getting here as 0, +1. These are all linear functions. These should end up in a straight line. So you can check to make sure you've got all these points correct. If you have a point kind of outside of where this line should be occurring, then check your math. My next point is +3, -1. And then +6, -3. Notice I can put my straight edge right through all of these points and put arrows on each side. and we have graphed our second equation using tables. All right, our third one to graph, or number 2 on our examples, 2x plus 4y equals 8. Notice this time we do not have y by itself. So the first step to solve the equation for y is necessary. Now we have 4 attached to y with multiplication, and we have 2x attached here with addition. Just like solving equations, we want to do addition, subtraction first, and then multiplication, division. So first thing I'm going to do is I'm going to move this whole quantity of 2x to the other side of the equation. 2x is positive, so I'm going to subtract 2x on both sides. Now, formatting, I like to put my variable first and then my constant. We'll get more into that in the school year. My next step, since 4 is multiplied to y, I'm going to divide by 4. When I divide by 4, I have to make sure everything gets divided by 4. So my equation now reads y equals negative 2 over 4 will simplify to negative 1/2 x, and positive 8 over 4 will give me positive 2. Now that I have my equation solved for y, I'm going to make a table for this. The values you choose for your table can be any value of x. I would definitely make sure you choose values of x that will fit on the graph. But the values of x that I'm going to choose are even numbers, since I have a negative 1/2 here multiplied to all those values of x. So this time the numbers that I'm going to choose are negative 4, negative 2, 0, 2, and 4. You can still choose these original values. I just like to choose a couple negative like I did here and a couple positive like I've done here. The numbers themselves, you can always use these negative 2 to 2, but I like to choose for problems that are going to clear out some fractions. So plugging these values in, negative 4 times negative 1/2, the negatives will cancel, and I can simplify the 4 and the 2 to a positive 2. And then I have 2 plus 2, so this will give me 4. My next part, plugging in negative 2, the negatives will cancel, the 2's will cancel to a 1, and then I have plus 2. So this will give me 3. 0 will cancel out the fraction, plus 2 will give me 2. 2 will cancel the 2, but not the negative sign, so negative 1 plus 2 gives me 1. And then 4 will cancel to be 2 over 1, so negative 2 plus 2 will give me 0. So my points are negative 4, positive 4. Negative 2, positive 3, 0, positive 2, positive 2, positive 1, positive 4, 0. Now that I have all my points and I can see that they're in a nice straight line, I'm going to connect all of those points and draw arrows. All right, so that is all we have on graphing linear equations using tables. The next thing we're going to talk about is slope. Slope is a measure of the direction and steepness of a line, a section of a line, connecting two of the points. Now in 7th grade, you learned about the constant of proportionality. If you had forgotten, the constant of proportionality was y over x. Slope is very similar to this, but instead of just y over x, we have the change in y, and that is a triangle. We're going to talk about that. It's a delta symbol, which means change over the change in x. So let's write that out verbally. Slope is the change in y over the change in x. We denote slope with the letter m, just like you denoted the constant proportionality with k. So this time slope is represented by the letter m. Let's first see this graphically. Vertical change can be represented as a change in the y values, because if you're talking about how something is changing on a graph vertically, it is how it is changing on the y-axis. Our horizontal change can be represented as the change in x, because if we were talking about how this is changing horizontally, it is actually how the x values have changed over time. What is the vertical change between the points A and B? Well, we can see on our graph here A and B. The vertical change between A and B, I'm going to count 1, 2, 3 blocks. So the vertical change between A and B is 3. Then I want to find the vertical change between A and C. So this time I'm going to go from A all the way up to C. Now, the vertical change here is not fully laid out for you, so I'm going to draw this line all the way up until I meet where C is. So this time I'm going to recount 1, 2, 3, 4, 5, 6, and I get all the way up to the vertical of where C is located. So this one is 6. Now I want to know the horizontal change between those same points. So the horizontal change this time between A and B, I can count this line here, 1, 2, 3, 4. So the horizontal change between A and B is 4. Now here we are at A, and we want to know the horizontal change between A and C. So this time I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. All right, the next thing we're going to do is we're actually going to put this whole process together. So I'm going to pull this back up to our definitions. The slope is the change in y over the change in x. Our vertical change was our change in y. So all over here, our vertical change, these both represent change in y. Once again, that's the delta symbol for change. The horizontal change can be represented as the change in x. So our horizontal changes here are a change in x. So finding the slope of the line of points A to point B, I want to know what m equals. In our definition, we wrote that m equals the change in y over the change in x. So I'm going to rewrite that as the change in y over the change in x. Now between points A and B, the change in y was equal to 3. And for the change in x between A and B was equal to 4. That means our slope, I'm going to just rewrite this as m equals 3/4 between points A and B. Next, between A and C, same process. I want to know my change in y over my change in x. Between points A and C, my change in y was 6. And between A and C, my change in x was equal to 8. We are going to simplify that fraction. 2 goes into both of those evenly. So this will drop down to 3, and this one will drop down to 4, dividing both of them by 2. So I can rewrite this slope as 3/4. What do we notice between the points A and B and the points A and C? Well, no matter what, their slope simplified to the same number. That will happen on a graph because the slope of this line is the direction and the steepness of it. So it doesn't matter what 2 points you pick on a graph, they will always simplify down to the same slope. All right, so without given a graph, we're going to find slope between 2 points. The first thing we're going to do is we're going to calculate the change in y. Now, if we don't have a graph to actually count those numbers, we're going to find this by doing y2 minus y1. Basically, what we're going to do without a graph is we are going to find where the y value is for one of the points and where the y value is for the other points and subtract them. And that will give us that distance between with our vertical change. Same with our change in x. We are going to find x2 minus x1, which will give us the horizontal change between 2 points. Wherever this x value is located and this x value is located, if we subtract their x values, we will find that distance between without actually having to count it. Step number 3 is to divide the change in y over the change in x. Because m, we wrote already, as the change in y over the change in x. So our slope equals this, and we just said the way we're going to calculate this without using a graph is by subtracting the y values and subtracting the x values. So I'm going to continue this on as y2 minus y1 divided by x2 minus x1. This will give us our number slope without having to count on a graph. Let's do the first one together. The ordered pairs that I'm going to give you are -3, 11 and -1, 15. Now it doesn't actually matter which one is x1, y1 and x2 and y2, but it is a good practice to label these. My first ordered pair, I'm going to label first as x and y because that's how we graph points. And this is also its own separate x and y. Now I'm going to label, because this is my first point listed, I'm going to label this as x1 and y1. And I'm going to label this one as x2 and y2. Those are just subscripts. If you're used to a superscript, like an exponent, these are very similar, but it's a subscript. Okay, so next thing I'm going to do is I'm going to plug those in to my slope formula. So I'm going to say m equals, and it starts with y2. So I'm going to go over here where I labeled y2 as 15. And I'm going to subtract y1, which is 11, divided by the change in the x values. x2 was -1. And I'm subtracting x1, which is -3. Notice with this double negative, I'm just going to put that in parentheses for now. Simplifying this, I have on top 15 minus 11, which is 4. On the bottom, with this double negative, minus minus, I'm going to change that to a plus sign. And I have -1 plus 3, which gives me 2. 4 divided by 2, because we always want to simplify, gives me 2. So the slope between these 2 points on a graph is 2. Okay, let's move on to our next problem. Your next problem contains the points 17, 3 and -1, 6. If you would like to pause the video and try this problem out, go ahead and pause the video now. Alright, so the first thing I did with this problem is I went ahead and labeled my x1, y1 and x2, y2. And I plugged them into the appropriate spots. I made a little typo here, so please ignore that. But I started with my y2, which was 6, and my y1, which was 3. And then I went over to x2, which was -1, and I subtracted my x1, which was 17. So on top I had 6 minus 3 to get 3, and -1 minus 17 to get -18. 3 goes into both those evenly, so I did simplify this. What I did with the negative sign is I just put it on the outside. The negative sign can be written on the outside, the top, or the bottom, but this does simplify to 1/6. So my final answer for my slope is -1/6. All right, let's try another one out. Number 3. The points are 11, -8, -7, -8. If you'd like to pause the video again, go ahead and try this problem out. Alright, the first thing I did, as you can see, is I labeled my x1, y1 and x2, y2. Once you feel more comfortable about calculating slope, you do not have to label those every time. But I plugged them into the right spots, and I started with -8 minus -8 over -7 minus 11. This double negative here I changed to a positive, so on top I have -8 plus 8, which is 0. On bottom I have -7 minus 11, which is -18. Well, 0 divided by anything gives me 0. So my slope between these 2 points is 0. All right, let's flip over to the back side. Our last concept for linear functions, and this is not the only concepts we have for linear functions, I just wanted to give you all a little insight to what we'll be doing in algebra. We're going to graph these functions using slope-intercept form. Now, we actually use slope-intercept form on the front side, but now we're actually going to talk about what it is. Slope-intercept form of a linear equation is written as y equals mx plus b. M and b actually get replaced as numbers. M, as you remember from the front side, is the slope. And b is going to be the y-intercept, or basically where the line crosses through the y-axis. Just like before on graphing it using tables, we want to make sure this equation is solved for y, since y equals mx plus b is also solved for y. The next thing we're going to do instead of making a table is we are going to plot the y-intercept. Once we have it written in y equals mx plus b, as we wrote here, b is the y-intercept, all you are doing is you are plotting b on the y-axis. We're going to plot another point using the slope. Located in slope-intercept form, it is this m which will be attached to the x. The next thing you're going to do is draw a line through the points, and once again, make sure you put arrows, because these also are a linear equation that is continuous. All right, number 1. Our equation is y equals 3x minus 1. If you notice, this is already solved for y, so our first step is done. The next step is we're going to plot the y-intercept. Well, if we go back to the top, we have y equals mx plus b, where b is the y-intercept. So here, it's usually plus b, and in the equation we have minus 1. That means our y-intercepts, or b, equals -1. So your y-intercepts, I'm going to go over to the y-axis, which is this one right here, and I'm going to plot -1. The next thing we're going to do is we're going to plot another point using the slope, or m. Well, m is attached to x. So here, the one attached to x is 3. So I'm going to write slope, which is my m, is equal to 3. Now, when we plot this slope, we need to know basically what this slope is representing. Well, we have a change in y over change in x, just like we discussed on the front side. Notice here we only have one number. How could we make 3 into an actual fraction without changing its value? Hopefully you kind of thought about putting this over 1. So where 3 is your change in y, and your 1 is your change in x. So from that point, we graphed first the y-intercept. We're going to plot another point using our change in y, or our vertical change. So I'm going to go up 1, 2, 3, and our change in x, or our horizontal change, over 1. Both of them being +3 and +1. You could continue doing this up 1, 2, 3, and over 1, as long as you need to make that line. We're going to talk about also how you can do this going backwards, but let's draw our line first. So connecting those 3 points to make a straight line, I kept this going on forward and backwards since this line is continuous, and I'm going to put arrows. Now the next thing I'm going to do, like I said, is I'm going to show you how this +3, +1 is also the same going backwards. From my y-intercept, my next perfect point is actually -3 and left 1, which gives me -1. So this also means the same thing because -3 divided by -1 gives me a +3. So you can also go forward and backwards with your slope. All right, so let's move on to number 2. The equation is x minus y equals -2. Notice this equation is not solved for y. So the first thing I'm going to do, just like the front side, I'm going to get this x quantity to the other side of the equation first before I divide. Now the x itself is a positive x, so the first thing I'm going to do is subtract x from both sides. This will give us -y equals -x minus 2. Once again, I like to list my x value first and then my constant. These are not like terms, so we can't combine them. And the reason I'm listing my x first, you know now, the slope-intercept form lists the x first with the slope, and then the constant, which is the y-intercept. But notice this equation is not finished yet. It's not y by itself. We have -y. So my last step is to divide everything by -1. This will simplify to y equals -x over -1 will give me a positive x, or positive 1x, and -2 over -1 will give me a positive 2. The first thing we're going to graph now is the y-intercept, which is our b term. So I'm going to put to the side here, b equals, this time it is positive 2. So I'm going to go up to my y-axis, and I'm going to go up this time to positive 2, and put a point there. My slope that's attached to x, there's no number here. When there is no coefficient, it actually has an invisible coefficient, and if you want to write it in, it is 1. So I'm going to write to the side here, m equals 1. In order to graph my slope, though, I need some type of fraction. So I'm going to make this over 1 for my change in y over my change in x, because 1 divided by 1 is still just 1. From my y-intercepts, I'm going to go up 1 and to the right 1, since they're both positive. And I can continue to do this, up 1, right 1, up 1, right 1. Just like we learned on the previous problem though, I can also take this backwards by making these both negative. Instead of going up and to the right, I'm going to go down 1, left 1, down 1, left 1. Noticing though that all of these are still falling on the same line. All I have to do is graph my line. When you graph these on homework, you only need a couple points to actually graph the line. I'm just showing you multiple points for multiple options. All right, number 3. Our equation is y equals negative 2/3 x plus 1. All right, graphing first my y-intercept, because this is already y equals, my y-intercept is positive 1. So I'm going to put b equals 1. And I'm going to go over to my y-axis, and I'm going to plot my points on positive 1. Next thing I'm going to go for is my slope attached to x. This time it is negative 2/3. So I'm going to put my slope as negative 2/3. This time I am given a fraction, so my change in y over my change in x is very easy to identify. And like I said about the negative sign, it can go to the top, it can go to the bottom, and it can also go to the outside. So the first thing I'm going to do is I'm going to graph from my y-axis, my y-intercept, negative 2. So this time I'm going to go down 2, and then to the right 3 for positive 3. Down 2 if I want to go again, to the right 3. Now, this negative sign, I can also move it down with the 3. If I move the negative sign to the 3, that means my change in y is now a positive 2, and my change in x is to the left 3. Notice though this falls on the same exact line. And then I'm going to graph it. We will talk more about this when we actually have class on linear equations, but I want you to see the difference now in these positive slopes of 3 and the negative slope of negative 2/3. This positive graph is going up from left to right, and this negative graph is going down from left to right. So that's a good indication that you have the slope going in the correct direction. So this slope was positive 1, so left to right, my graph should be going positively. Number 4 is 4x minus 3y equals 6. If you want to pause the video and try it out, you are welcome to pause the video. If not, work it with me in about 2 minutes. Alright, hopefully you noticed this y was not solved for. So the first thing I did is I moved the 4x to the other side. It was a positive 4x, so the first thing I did was subtract 4x to both sides. Then I divided by negative 3 because negative 3 was attached to y with multiplication. When I simplified, this negative 4/3 became a positive 4/3 x. And this 6 over negative 3 divided out to negative 2. All right, hopefully you got your equation in slope-intercept form. The next part is graphing. So graphing this function, my y-intercept was negative 2. So I put to the side here, b equals negative 2. And my slope attached to x was 4/3. So I have here, my slope is 4/3. So when I graphed this, I first graphed my y-intercept on negative 2, and then I graphed up 4, positive 3. I also graphed this point down here by making them both negative. -4, -3 would also give me a positive 4/3. Also, my 4/3 here being positive, you can see my graph from left to right is going positive. All right, very good. Hopefully you're learning something new, a little bit about linear functions. Our last part here, I gave you each of these graphs. What we're going to do with these graphs is we are actually going to write these equations in slope-intercept form from the graph. So the first thing we need is we need to know what the y-intercept is. The next thing we need to know is what the slope is. Once we know what b equals and we know what m equals, we can write our equation in y equals mx plus b form. So the first thing I'm going to do to find the y-intercept is I'm going to look at the y-axis. If I go down the y-axis here, I can see the equation crossing through at 0. So my b value this time is 0. Next thing I'm going to do is like the front side for calculating the slope. You could pick two of these points and you could calculate it using y2 minus y1 over x2 minus x1. Or you can count the change in y over the change in x. Our next perfect point here is either this 4, -1, or you can also see another perfect point on -4, +1. Now, when I calculate this, I can see first of all, from left to right, this graph is going down. So I know in the end my slope should be negative. Calculating or counting from this point to this point, my first vertical change goes down 1. And my horizontal change to get to that point is over a +4. So vertical change of -1 over my horizontal change of +4. You can also calculate it back to this point if you want. But this time to get to that point, you're going up 1 and left 4. But your vertical change over horizontal change also gives you -1/4. So when I write this in slope-intercept form, I'm going to put y equals my slope of -1/4 plus my y-intercept of 0. You can either put +0 or you can leave that off and just put y equals -1/4 x. But if there is nothing attached to the outside, that just means it crosses through at 0. Okay, number 2. First, identifying my y-intercept, I want to know what b equals. So going to my y-axis, I see that it crosses through at +2. Finding another perfect point, I can see here at 3, 3. You can also find another point back here, but you only need 2 points to find your slope. So I'm going to write m equals, and you can either calculate those two ordered pairs or you can count on your graph. This time, to get to that point, I have to go up 1 vertically and right 3 positively. So this time my vertical change is 1 and my horizontal change is 3. Plugging this into slope-intercept form, I get y equals 1/3 x plus 2. And that's it. All right. Your next graph here, if you want to try this one on your own, go ahead and pause the video and try it out. All right, looking at my graph, I first identified that the y-intercept was +3. Then I picked another perfect point, which was directly on the arrow, so you could also pick a point back here if that helped. But I found the vertical change this time was 2 and the horizontal change was 1. So 2 over 1, or you can simplify that to 2. Notice this is working backwards, exactly what we did to graph that slope. The last thing I did was put it in slope-intercept form as y equals 2x plus 3. All right, last problem. If you want to try this last one on your own, go ahead and try it out. First thing I identified again is I noticed it crossed through at positive 1 on my y-axis. Then I picked a point, another point on my graph. In order to get there, I had to go down 3 and to the right 1. Negative 3 over 1 simplifies to negative 3. Checking this off, you can always check off your slope ending up either negative, left to right is decreasing, or like our previous problem, positive, left to right, our graph is increasing. So here I have my y equals negative 3x plus 1. All right, try the homework out. If you have any questions, please feel free to email me, as this is a very brand new topic compared to something you may have done last year with equations or inequalities.